on the important regions. Like I'll go ahead with my modules. Here is my entire project explanations. Like I'll consider an image from like I'll extract the data sets from Kaggle as well as from UCI University of California data sets. First, I'll augment data augmentation will be done, sir. Like when an image is considered, sir, and image will be undergone with some translations of some images, like uh, pixelating the images, cropping the images. Some translations will be done on that images, sir. And then data pre-processing steps, like we'll remove the noises and unnecessary data, like redundancy of data, like that unwanted data will be removed, sir. And then the next step is images annotation, sir. Like before getting it trained, we'll annotate the images, like we'll mark
Your
the.
mouse where you are explaining? Keep
Yeah,
your
sir.
mouse moving where you
Yeah, sir. Here is images annotation, sir.
right.
And yes, sir. And in this multitask net, fusion net, and global net are under the gastronet algorithms, and this helped me a lot to improve my accuracy in my projects, sir. Like the multitask net will handle multiple tasks at a time. Like I'll extract the data from multiple sources, like from Kaggle as well as from UCI. To handle all such tasks, the multitask net will be helpful to me, sir. And the fusion net is helpful to combine all the data sets, like it will consider all the data set from the sources which I have retrieved. And this global net, when I have annotated the images, this will focus on particular area to detect the cancerous cells. Like the image that I have given as an input is a tissue cells. Like after getting pre-processing done and that data set is well trained, when an test data is given as an input, a future extracted model file will be generated, sir. Like it will predict the disease, like whether the cancer is present or not. Like if it is present, it will segment the cancer areas, like it will output, like you will have a clear idea when I show you this one, sir. I'll collect the data set, and 75% of the data is training data, and testing data is 25%. And I'll collect the data from Kaggle as well as from UCI, that is from third party websites. And data pre-processing will be done, sir. And annotating the images, like I'll mark the images, sir. When an image is given for an input, I'll use here to annotate the images and to pre-process well and to train the images well. I'm using Make Sense AI, sir. When an image is given for an input, it will pre-process the data, and it will remove the noises as well as redundancy data. So I'm using here the Make Sense AI to get the better results, sir. Like after annotating images, it will be output for training, sir. And here, the as I have discussed earlier, here I'm using a multitasknet, fusionnet, and globalnet. And it is like it will under the architectural diagram. Yes, sir. I'll show you my input and output, sir. This is like images that I have collected from Kaggle and UCI, sir. That is, I'll annotate the images. Like when I consider a particular image, it should be like whether the cancer is at a stage 1 or stage 2. Like I'll mark the data sets, sir, through Make Sense AI. And when an image, random image, like a tissue image, when I given this image, it should be pre-processed. Like I will reduce the size of it. Like these are some pre-processing techniques. Like when an NumPy array is given, like to reduce to a particular amount of size. So these are some pre-processing techniques. And when an image is given for an input, it will predict the cancer at what stage is it, sir. Like I'll go ahead with my outputs. These are some modules that I have developed here. And yes, sir. This is normal, sir. When an image is given, like a tissue cells, like I'll show you, sir. Input. Yes, this is a input image, like I have given as an input, and this is my output. Like it will detect. And when annotating the images, once after annotating, and once after training the data, once after giving the test input, and it will predict final the output images, sir. Like it, like completely black in the sense the ratio of black is to white. Like it was normal, sir. Like completely black images. And when coming to the stage one, like it, if it is less than 30%, white percentage area was less than 30% means the cancerous was at the stage one, and after greater than 30% means like it was at the stage two. So the main theme of this project is like when we detect the cancer as early as possible, so we can diagnose the patient, no sir. So this is my final theme of my project, sir. Like